lecture. One will be called first and then the second one.
Hello. Hello. Hello, hello. Good afternoon and welcome to Estrad. Today is a very special day. This lecture is number 200 since we started 1997. My name is Helen Torgrimsson and I've had the privilege to work with Estrad lectures for many, many years. It has been a lot of interesting topics, great lectures, and today is no exception. Fredrik Heinz and Nassim Farahini will soon present interesting findings. But first, I want to share with you how Estrad was born once upon a time. Espri's managing director, Magnus Aronsson, knows all about this. So please, Magnus, come up on the stage.
Thank you, Helene. Actually, it was almost 21 years ago on October 2nd that I was standing on a stage not far from here in another venue and stood in front of a much smaller audience to introduce the first speaker of the what later called the Estrad Open Lecture Series. And from the outset with these, we had a vision and an idea that these open lectures should be a platform and a stage for researchers to be able to share a research beyond the university walls and the scientific publications that they write in. Also, from the outset, we wanted to be as inclusive as possible and really reach out and enable and really work hard so we could get as many entrepreneurs, innovators, people working in the private sector coming. And if you looked at and we did that from the beginning, and if you look at the participation list today, you will see that this is still the case today. So before today, the previous 199 lectures, we've had over 24,000 participants in total and 329 speakers performing on this stage. And many of them are top scholars from Sweden and from abroad. And today, given that we had our 200th, that's quite tricky, open lecture, we decided to do it a little bit different. So we wanted to look a bit into the near future. And focus on one of the hottest topics at this moment. One could really say, when we start looking at this, that artificial intelligence is really the new black when it comes to discussion about technology and development in society. And AI is what we will focus on today. And this afternoon we'll learn more about AI and discuss what AI is and how it could impact both businesses and society. So, just to give you a short introduction about the format so you know what you will expect this afternoon for the next hour and a half. We'll start off with two speakers that both come from academia, have an academic background, and then we'll complement their presentations to bring up a panel with three more speakers. I'll come back to that. And we'll also have time for Q&A at the end of this session. So, you don't want to hear too much from me, but we're here for one of the main speakers for this afternoon. First up on stage, I would like to welcome Associate Professor Fredrik Heinz from Linköping University. He's also the president of the Swedish AI Society. Fredrik, welcome.
Thank you. So it's a great pleasure to be here. It's kind of fun. This is my third talk today. Speaking of AI being popular these days. And I guess I will also be the boring academic, not giving you the shiny future AI will solve everything, but rather try to be a bit more, modest or realistic, and try to see, what can we really expect, and be a little bit more realistic, I hope. So actually, I seem to do a lot of this kind of expectation management these days. Anyway, I think it's really interesting with AI. As you all know, it's so much discussions these days around this topic, basically from every part of society, every company, every organization, and so on. And I think it's quite easy to consider when there are pictures like this in the newspapers. This is KJ, 19 years old, after he has lost against Google DeepMind AlphaGo last year. And he looks a little bit sad. And after the game, he gave an interview where he said that he would never stand a chance to ever beat the computer because he was playing like a god. And he felt that he would never have a chance of achieving the same capacity and the same skills. And it's actually quite interesting to watch these games and to see what did the computer do. So in one of the games, the computer made a move that all the expert commentators thought that the computer made a mistake, because it made a move that no human has done before, at least no one that done it in a successful way. And then, I think it was like 14 moves later on, the computer used this move in order to turn the game around and actually win the game. So we have to keep in mind that it's not just kind of copying what we are doing, but it's found new strategies, new ways of playing this particular game, Go. So it is clear that it's not just repeating what we are doing, but actually finding new ways of doing things that we believe that we are the best at doing. So of course that begs the question of what is artificial intelligence? And this is the picture I've been using for some time now. I've been using the definition by John McCarthy, who's one of the founders of this research area. So basically, he sent in a research proposal in 1956 saying that, can we please have some money to study this problem of artificial intelligence? We plan to solve it in 2 months. And of course, now 60 years later, we are still working on it. And I'm pretty sure that we'll be working on it for another 60 years at least. So anyway, he defined it as artificial intelligence is the science and the engineering of building intelligent machines, especially intelligent computer programs. And I think this is kind of an interesting definition because there is no well-established definition of intelligence. So many people argue this is just a circular definition, you haven't really defined anything. But what I think is interesting is that the way to see it is usually that you want the computer to be able to do things that currently only humans can do. And since we attribute everything to our intelligence, we say it's intelligence. But I think it's interesting. It's basically, it's really the problem of how do we get the computer to do new things, things that it couldn't do before, which currently only humans can do. And I think it's also interesting to, it could take basically two major approaches. Either you can start to study human cognition, human intelligence, and try to build computer systems that do the same thing as we do, trying to emulate the cognitive processes that we have. Or you can try to understand what intelligence is and build a more engineering approach to it. So it's basically like, if you want to build a flying machine, you can either study birds and try to build a mechanical bird, or you study birds and then you learn aerodynamics and then you build an airplane. And I'm taking more the second approach, trying to have more general understanding what intelligence is and then building engineering solutions based on that. And normally what we focus on is not really building this kind of complete intelligent agents that kind of have everything. I mean, having perception and reasoning and action and so on. But what we're more using is this kind of cognitive components. And I think one of the two main cognitive components is reasoning. So doing rational reasoning or logic-based reasoning, the kind of general analytical skills that we are very good at. I mean, problem solving, planning, and so on. And that's what I call reasoning here. And that was basically the major focus of the previous, last AI hype. The current AI hype is really very much around learning. So where you want the computers to learn new things or adapt what they already know. Because, I mean, one of the lessons from trying to build this kind of expert systems and capturing human knowledge and being able to reason with it, it's that really hard to capture human knowledge. So therefore, learning is really essential these days. And what I think will be the next major step is the interaction, where you're also able to interact with these systems in a natural way to produce interesting results, because it's kind of boring to have a super smart black box standing in a corner not really doing anything. So that's kind of what intelligence is, or artificial intelligence. I think it's also interesting to relate it to digitalization. So here's a slide I borrowed from Göran Lindsjö, where he kind of separates the difference between digitalization and AI, which I kind of like. That digitalization is basically trying to make the world square so that it fits into the computer. We want well-defined problems, predictable situations, structured data, rationalized things. While in the AI corner of this diagram, we're really interested in solving the other problems, the ones that we cannot easily make square, the problems that kind of escape proper definitions, the unanticipated situations, the adaptable solutions where we need to change the way we are doing things as we move along, and where we can handle unstructured data instead of just the kind of structured data. So I think that's a good try to separating these. And then if we look at a little bit more techniques, I mean, it's pretty clear that the type of techniques that are having the most effect are kind of being mostly used these days, and where most of the real applications come from is from what we call supervised learning. So it's basically, instead of defining the rules of the program or writing down a program which solves a particular problem, you rather take a large set of examples. So here is the example input, and for this particular input, what is the correct answer? And then based on a large collection of these examples, the computer itself finds the proper boundaries of this and tries to find a mapping from inputs to output. So basically learning a new function, so it's a function approximation method, which works really, really well. And we can see many different examples here, like taking images of faces and associating it with names, or taking voice recording and then doing a textual transcript from this, and so on. So basically trying to predict things, trying to classify things, and so on and so forth. And this is the major class of solutions that we do. But there are, of course, other types of machine learning techniques. For example, unsupervised learning, where you're more trying to find clusters or patterns in the data, and what's called reinforcement learning, where you basically learn through trial and error. You try something, you get feedback. If you get positive feedback, you try to do more of that. If you get negative feedback, you try to avoid it, kind of like humans learn. And the really interesting systems usually combine these in different ways, because there's not a single method that will solve everything, but rather you have to combine different methods to get really good results. And we also have to keep in mind that machine learning is still very brittle. So this is an example a couple of years old, but I'm sure any system that exists today can be fooled like this. So you have, in this case, it's an image of a panda that's being correctly classified. We add something that may look like noise, and you get an image that to us humans looks exactly the same. But for the computer, it looks completely different. And the reason is that it doesn't see the kind of overall shapes and so on, but it will look at every individual pixel in this particular image. And since we've changed every pixel a little bit, it means that every pixel is different and the image is completely different to the computer. And in this case, it classifies it as a monkey, a gibbon, with very high confidence. And this is classified as a nematode. So we can see that one of the challenges with these methods is that you will not get an exact answer and you will get no guarantees exactly what they've learned, but in most cases they work really well. Which takes me back to the human cognition. Many of you probably heard about this book, Thinking Fast and Slow by Daniel Kahneman, who received a Nobel Prize, I think it was in 2009, for research that he did together with Amos Tversky, where he was studying human cognition. And that they found that it seems like we have two levels, two systems that work together. We have the system 2, which is the slow level, which is kind of our deliberate, explicit reasoning faculties. That's where we do our explicit planning, our explicit analytical reasoning, where we have this kind of introspection. We are aware of what we do and how we do it. And that is really this reasoning part that I showed earlier. On the other hand, what we have is this fast system, which is basically unconscious, effortless, and we have absolutely no clue how it works. I mean, I'm sure that none of you can explain how are you recognizing faces. How do you do when you recognize a face? What are the things that you catch onto? Or how do you navigate difficult terrain? I mean, if you're out walking or running, how do you do it? And I think this is where these new techniques are. Basically, this, for example, these deep neural networks that are very popular and working well, very well in many situations. You basically have a black box that seems to work most of the time, but not every time. And we have no clue exactly why they're working, but they're doing it very well. So, of course, we have two aspects here. First aspect is that this is kind of the ideal. This is where we believe that we do most of our important work. So that's kind of where we want to be. But now we see that the methods that actually work are more on this side. And the question is whether do we need to change our ideal? Can we even expect to have these guarantees all the time? Is that reasonable to think that? Or should we try to combine these in a systematic way? I like to combine things, so of course I believe that is the way forward, but we'll see. So why is this important? So I mean, what are the kind of opportunities this opens up, but also kind of leading to challenges? So first of all, I mean, this machine learning allows us to detect or extract complex patterns. So now we're able to solve problems which we cannot really explicitly define what they are, as long as we can show examples. This is one of those. This is not one of those. Okay, here are the examples. Learn from that. And so basically, doing a lot of the work that we are doing ourselves before. And machine learning also allows adaptation, so you can adapt your system or product or service to different types of users depending on where they are. And you can also adapt the system as it's running, so you can adapt over time, which basically opens up for data-driven decision-making and optimization. And since these systems are able to cope with very large and complex situations and amounts of data, it means that we don't really need these kind of hierarchical organizations that we have building up over the decades or centuries in order to cope with complexity. I mean, the main way for us to cope with complexity is through hierarchies. But now we don't need these hierarchies anymore because these methods are powerful enough to deal with cross-cutting concerns and also deal with them in an optimization fashion, which means that we need to change the way we work. And I think if we see at the two main things that these, especially these deep neural networks have been able to solve very well is image recognition, or everything to have to do with image processing, and everything that has to do with natural language processing. It's kind of the perception part of us humans. And now the quality is quite high. And now we can start using natural language both to interact with the computer, but also that the computer can start to reason and collect and process natural language information. And to me, one of the key things with AI is that you're really moving decisions from design time to runtime. So instead of thinking about every possible situation ahead of time and then building a system where we do exactly what you expect it to do in every situation, now you're building a general solution that will be able to observe the particular situation that it's in and make an optimal decision in that situation. But you don't know exactly what that optimal decision would be because it depends on the situation and so on. I haven't talked about robots, but I think robots are really interesting as well because they give us physical presence anywhere. So I gave this talk previously, and then I had a colleague of mine that came up and said, yeah, one of the kids in my kids' class got sick and had to be in hospital for several months. But then they had a robot in the classroom, and this kid could kind of be part of the class and participate in the teachings through the robot and be part of the social environment of the class. So I think that's a really great example. And of course, knowledge work is ripe for automation. But let's take a step back and talk about chess again. So chess is, as you all know, a game where we humans don't have a chance against the computer. We haven't had since 1997 when Garry Kasparov lost against Deep Blue. But the quality of human chess playing is increasing because we're playing against these automated systems. And if you combine humans and chess playing machines together, they're better than both the best humans and the best computers. But what's really interesting here is that it's a different skill playing chess without a computer compared to playing chess with a computer. Which means that if you have an expert, currently an expert, that is an expert in solving whatever problem that person is doing without a computer or without these tools, and you give that person a tool or a really good tool, that person will probably not be better, might even be worse, because you need to change the way you work and you need to learn how to do this with the tool. And I think this is a really important lesson, and at least here in Sweden, there's kind of this tendency to throw out computers or iPads and so on into schools, and then say, oh, and then get surprised that the quality of the education didn't improve just because we threw out all these computers. But of course, you need to change the way you do your teaching. I mean, the pedagogy has to change in order to leverage these tools. And of course, you need to educate the teachers in how to use them. So I think that's a very important message. And the second message is also, of course, that it's not either or. It's not either machines or humans, but rather that we need to work together in order to solve the complex problems that we are facing. And in order to do this, I think education is absolutely crucial. And that's why I've also been very active in education. So I've been part of rewriting the Swedish national curriculum, where we now have programming from first grade as part of the law. So all of you that have kids in school, please go home and check. Are they learning programming in school, and are the teachers well prepared and trained for this? So that was one part, but there's also this digital competence. So again, in the new curriculum, there is an increased focus on digital competence. What I stress very much is what we call computational thinking, which is really, I mean, how do you solve problems in such a way that computers can be part of it, that you can use computers as part of the problem-solving process. And I think programming is actually one example where you are using the computers to do this. So I think programming is actually one of the best ways to learn computational thinking, but it's not necessary. I mean, as I said, this competence is really crucial, and so actually there's been a new effort from the government to increase the get the universities become more active in professional development. We haven't been very active, which I don't think is a good thing, but we have to be more active in providing courses and teaching material and different activities that are more suitable for people that are already working. And I already mentioned this with organizations, so I think, I mean, of course, AI is a technical field. There's a lot of technical challenges and technical solutions, but I also think it's equally important that if you start using these tools, introducing them into your organization, into your companies, you also need to change the way that you work and the way that you organize your work. And I think it means that it's equally important to do business and organizational development as it is to do the technical development. And I think this is also, again, one of these important lessons to learn. And here is I think we have a challenge in Sweden, and that is that for most companies, the companies are doing really, really well. Most companies are doing extremely well. They have a hard time just keeping up with the orders and delivering the goods that people want from them or the services that they want. So I would say that we are kind of here maybe at the peak here. Everything is going really, really well, but you don't know what's going to come tomorrow. You don't know if there will be a Chinese startup that will do the same thing as you do, but at half the price, and they will change twice as often and individualize, and yeah, I don't know what. They will just take over the market really, really quickly. And I think there we have a challenge there, because organizations need to look into the future, that even if you're doing really well today, your products are great and your services are really well enjoyed by the customers, but you still need to look into the future and see how to change and be prepared for the next step. And now I think he's getting a little bit nervous here. So to my final slide. So what I think is really important is that the only thing we know is that we don't know enough. So everyone needs to learn more about both how can we use these techniques, but also what can we do with these techniques, and how can we introduce them into our organizations? Because there are so many things they can do. Basically anything that's involving, for example, prediction, you can apply this kind of machine learning methods. Anything that has to do with classification or segmentation, for example, marketing, trying to find different groups of customers, or customer support is something usually that's being automated very much with chatbots and so on, that you get a uniform interaction with your customers that's really rapid and cohesive. And so there's so many different things that you can do within your organizations. But unfortunately, I don't think you will be able to buy AI in a box. So say, oh, let's buy 2 boxes of AI, plug it in, and then I'm done. No, you really need to understand how your business work and how these techniques can be used for you. So it's really need to combine the kind of technical know-how and the business and the kind of domain know-how. That's when you get the real interesting results. And I don't think you should do this kind of more side projects, but more find a real business problems that you cannot solve today with your existing methods or existing tools. Try to solve them. That's what's interesting. And of course, there are many off-the-shelf tools. And as I said, I mean, if you want to scale up, you need to change the way you do business and the way you charge for it and make money from it. So my kind of final concluding word is that it's not either or, it's both machines and humans. But in order to leverage these tools, we need to educate ourselves much more and to learn how to use these. And we need to focus as much on the business side as on the technical side. Thank you very much.
Thank you very much, Fredrik, for that 20-minute crash course in AI. Excellent. Thank you very much. Next speaker up is Nazim Farahini. She has a PhD from Royal Institute of Technology, or KTH. And then she left the academia to work first at Google in Silicon Valley, and now been back now in Stockholm, in Sweden, and work as a company called Quamcon, and where she's the CTO. So. And again, technology works, and the floor is yours. Welcome. Does it work? It's on.
Yes.
Michael.
Does it work? Thanks, Magnus, for the introduction. Thank you. Good afternoon, everyone, and it's a pleasure to be here today to celebrate Estrad 200 among you all. What I'm going to talk about today is that how the emerging technologies of AI, not only AI, but also IoT and cloud, could be exploited to improve the quality of life, environment, and the competitiveness of Swedish business. Let's start by artificial intelligence. Artificial intelligence can simply be defined as putting human intelligence in machines so that they are capable of learning, reasoning, planning, and decision making. Advanced machine learning algorithms are used to enable such capabilities. But these models need tremendous amount of data to learn by finding patterns in data. And today, this data is provided mainly by IoT. Internet of Things can simply be defined as things that talk to internet. Things such as sensors, smart meters, cameras, and even self-driving cars. It is predicted by IDC that by 2025, more than 70 billion connected devices will exist that are connected through internet. The generated data volume has reached unscalable proportions that cannot be handled manually anymore. So on the other hand, AI technology has improved to automatically analyze this data and extract useful information. Machine learning algorithms are very computation and storage intensive, and this requirement is fulfilled by cloud, which is a centralized high-performance computation platform. Similarly, fog infrastructure, which provides with computation and storage platform, but closer to the source of data or sensors. We are living in a connected world, and the growth in volume of data is phenomenal and is dominated by Internet of Things. Internet of Things or IoT objects generate 2 exabytes of data every day, meaning billions of gigabytes of data. A jet engine generates 20 terabytes of data per hour. Terabyte of data means 10 to the power of 12. A self-driving car can produce up to 10 terabytes of data per day. And it's interesting to see that more than 90% of world's data is created over the last 2 years. But more interesting, only less than 1% of this data is utilized today. So here is where IoT and AI meet. And at the merger of these two technology trends, we can think about development of systems and complex applications that were like dreams before. Systems like advanced healthcare. AI can scan through tons of collected patient data, find correlations, and prioritize patients with urgent care, with urgent needs, and help doctors to make better diagnosis and plan complex surgical operations. Thousands of sensors will be embedded in houses, offices, and in cities. And this is going to change the way that we interact with environment. Smartphones most probably will be extinct in near future because environment will be smart enough to understand us by recognizing speech, facial expressions, and gestures. We are installing sensors in remote areas that are difficult or even dangerous for humans to access, to monitor and automatically analyze environmental changes and make better predictions. It is possible to augment human intelligence and power through collaboration with machines, to make data-driven decisions to eliminate administrative tasks and repetitive tasks and free up time for humans to think and to innovate. These technological advancements not only have provided us with new categories of products and services, but also have reshaped the business landscape. In 1999, we see companies like General Motors and Ford that stayed for around 50 years among the top 10 companies in valuation are replaced at the turn of the century by companies that heavily provide, exploit, and contribute to digital data and AI technologies. Sweden has long been recognized as one of the most digitized and industrialized countries in the world. And I would like to share my vision on what Swedish business can do to exploit the emerging technologies and maintain or even further enhance its position. What I want to discuss next is how the four well-known phases in business cycle, which are predict, product, promote, and provide, how can they be adapted and improved by exploiting AI, IoT, AI and IoT basically technologies? And I will provide some examples. A completely new sets of opportunities are opened up that were not possible with older technologies. Prediction. It simply means accurately forecasting the demand to optimize supply and to optimally shape the future offerings. You can embed thousands of sensors in factories, in wind generation farms, bridges, and power networks to remotely collect data, automatically analyze it in order to detect anomalies and predict the need for maintenance. This preventive maintenance can increase the profit by minimizing downtime. You also can forecast the demand by installing cameras and sensors in stocks and stores and order only specific quantities of specific items that will sell to minimize the waste. This can be done by finding patterns in shopping trends and by anticipating the soon-to-be popular items. You also, AI also can anticipate the path of spread of disease and viruses and prevent epidemics. Let me find the mouse. Okay. Product. Consider example of a product line. We can increase automation by engaging teams of context-aware collaborative robots. In past, we needed to explicitly program robots, like bend the joint, twist it, and pick up something from a specific location. But now with advanced analytics, distributed decision-making, and advanced vision sensors, they can be assigned much more complex tasks, like go and pick up something that looks like this. And now you can integrate robots much more efficiently with people to work as a team. And this is the new automation approach in factories. You can also use robots to improve the quality by constant smart monitoring and detecting defects in manufacturing process and improve the yield. All this can improve the productivity and lower the cost. Promote. It is not only manufacturing and preventive maintenance that can benefit, but also marketing and sales aspects. Customer data is streamed through mobiles and other distributed devices to internet, helping businesses understand the state of the mind of customer and set the right price to increase the revenue. Depending on the nature of the business, the need for servicing varies a lot. But at the end, it means that you customize the service package based on user preferences. And this can benefit both the customer and the provider. One category of examples are industrial products, but another one is are like services that are provided by healthcare systems. As an example, based on historical data and real-time monitoring of patient condition, AI can suggest specialized cancer treatment, or it can optimize rehabilitation process for stroke patients by identifying or suggesting specific walking patterns. Okay, now that we have seen some examples of how these technologies can improve, there is something happened? Yeah, this. And here's where technology doesn't work. I'm trying to connect again. Yeah. Okay. Yep. Backup plan.
You can network for 1 minute while we wait.
So the question is if problem is with this or that. Yeah, let's see. No problem. Mm-hmm. Okay, good. Awesome, thank you.
Okay.
Back. Shh. All right, sorry for the problem. So now we have seen some examples of how these the IoT and AI technologies are impacting the business execution, and next I'm going to describe how we can implement them and what are the trade-offs that one needs to consider. The implementation happens on cloud and fog infrastructural technologies. And there are several variables that we need to optimize: bandwidth, latency, reliability, power, privacy, and security. But given the time that I have, I'm mainly focused on bandwidth and latency. But in one slide, I will show the overall trade-offs. Let's take a look at the cloud infrastructure. Cloud plays a central role in enabling and integrating AI and IoT by providing a centralized, high-performance computation platform at data centers. When the number of connected devices and computation demand is modest, this centralized model works by sending data to the cloud, analyze it there, and then sending back the control signal to the edge. But this model has limitations. With proliferation of IoT sensors at the edge of the network bandwidth does not scale. And there are many new applications that require real-time action. In self-driving cars, to avoid an accident, the action needs to be taken in less than 5 milliseconds, whereas the round-trip latency to cloud is 100 milliseconds. So this suggests that if you cannot send the data fast enough to cloud, move analytics closer to the edge. And this is what is called data gravity. So we add intermediate processing and storage nodes. And this emerging architecture, which brings processing closer to the edge of the network, is called fog, or edge computing. These nodes enable fast control loop at the edge by collecting data from sensors, analyzing them at gateways, and taking immediate action. Further, there are higher-level intermediate nodes to aggregate the data and to enable machine-to-machine communication. Further, you can filter the redundant data before sending it to cloud. Otherwise, it could cost you a lot. And we will see that with the help of an example. Cameras are very cheap today. Cost of a camera, including housing and even additional sensors, is dropping down to almost $5. But if you want to upload all the images that are recorded, it can cost you more than $2 million over the course of 3 years period, which is the lifetime of the camera. You might use advanced image processing and compression methods at the edge to bring this cost down. But still, it's more than 10 times of the cost of a camera. To keep the cost in the same range as the camera itself, we need to understand what is going on in the sequence of images. And here is where AI can help to automatically analyze the sequence of images and store only events of interest. Another fascinating example is ingestible imaging capsule that can be swallowed. It even has imaging circuitry and wireless transmitter. They're so small that we cannot put batteries on them. They're powered by sound waves. So the interesting question is that, how do you distribute intelligence between the device, gateway, and the cloud? Where do you put the data? And where do you do the processing and filtering the data? I want to get help from this diagram to explain some of the existing system trade-offs when you want to plan the flow of information and intelligence from edge to cloud. At one side, you have the edge with many sensors that collect fast data, we call it fast because we can act upon it immediately. And on the other hand, in cloud, we have aggregation of data from all sensors and historical and global data. And that's why we call it big data. System responsiveness is reduced by sending data to the cloud. But on the other hand, scope of analysis is reduced when you're moving to the edge, because in cloud you can do global analysis. Similarly, privacy can be compromised by moving, sending the data over the network, but computing and network costs can be reduced by moving to the edge, by paying upfront to buy hardware and do processing on premise. And of course, big cloud providers are also aware of these trends, and they are trying to expand the cloud offerings already to the edge. All right, let me summarize what I have discussed so far. So I have tried to explain the state-of-the-art applications and functionalities that are enabled at the intersection of the three mega trends of AI, IoT, cloud, and fog. But these technologies are still in their infancy, and there are huge opportunities there. Do I have 1 minute? Okay. So another thing that I would like to briefly discuss about is that with digital transformation, business models are also evolving, because now products have embedded sensors that are connected and can be synced, and activities can be coordinated. So consider example of a wind turbine. You can not only optimize the performance of individual product, but also the whole farm of products. So instead of selling a product, you can provide customers with services, with capacities and performance of connected devices that work as a system of systems. And just as an example, consider the automotive industry. If you are a car manufacturing company, and you have the idea of making money by selling products or selling cars that are 95% of the time parked in garage, then your business might be at risk in near future, because the competitor might have realized how to combine autonomous driving technology with smart instant scheduling and provide customers with mobility. So they can maximize utilization of the product over the lifetime of the product and monetize even the operational phase. I had a slide about like open questions, especially AI, but I guess this will be covered during the panel.
Yeah.
Yeah. Okay. Yeah. Thank you.
Thank you. Thank you very much. Thank you very much.
Thank you.
Now we're gonna just rearrange a little bit here, and while we do that, I would like to ask the two speakers to come up again on the stage, and also our three panelists. Additional three panelists: Margareta Groth, Head of Department at Vinnova, Sweden's innovation agency; Joel Hellemark, co-founder and CEO of Sunlabs; and Kristina Henriksson, Head of Division at the Swedish Agency for Economic and Regional Growth, Tillväxtverket. We're gonna take away that. We're gonna get another chair here, so another table rather. Now we're gonna move it over here. And then, so we have something for you to lean on.
All right.
And hide behind. There we go. We have two for you, five,
yeah.
and they are on. See?
Nice. Yeah, I have a microphone.
You have one. But Helene wants that because for the Q&A later. And we'll share there, and we're going to just move this behind you here. See? Instant. And we do it without AI, just with I. And I'm going to use that. And if you can sort of share, you can share with me here. So it's 2 and 2 and 2. So yes, excellent. And you have to steal that when you can talk. So yes, I would like. We have 3 new people here up on the stage, and I would like to start off with Joel, just for a minute or two, just briefly. What do Sana Labs do?
Of course. So yeah, this one works.
Keep it close to your mouth.
Perfect. So my name is Joel Hellemark, and I'm the founder and CEO of Sana Labs. And at its core, what we do at Sana Labs is use AI to provide personalized education. So we provide a platform which makes it very easy for the world's education companies to incorporate AI into their products to provide personalized learning experiences. And what that means is that every single student receives personalized content based on how they learn, what they've already mastered, and what works best for similar students. So rather than sort of a traditional one-size-fits-all model, it gets dynamically personalized based on every single data point that's being generated about those students. So in Sweden, for example, we've partnered with Nationalencyklopedin, who are big in digital tools, and we're working on providing this for mathematics. So it's currently running personalizing maths for year 4 and 5 students. But we're a global company from day one, so we also have partners in the US. We're working with some of the world's largest publishers based out of there to provide personalized education at scale. And really what the sort of core function is, that where we think AI can be helpful, is that we're never going to be able to provide every single student globally with a personal teacher. But using technology and artificial intelligence, we might take aspects of what has historically been done by a teacher, personalizing the curriculum, giving a set of questions that's on your exact knowledge level, addressing your knowledge gaps, and provide that through digital systems at scale. And that's really what we're passionate about, bringing personalized education to everyone, everywhere.
Great, thank you. And I will, Margareta, Ruth?
Yes.
It's on. Keep it. Yeah, it should be on.
It's on.
Keep
I'm going to keep it close. So I'm Margareta Groth, head of one of the industrial technologies department at Vinnova. But currently I'm also co-chairing our task force for what kind of investments we are going to do in AI. So I think that's why I'm here today. Most of you know that we published a report earlier this year on AI and what Sweden's AI potential is. And it's available in English as of yesterday. So I know that Magnus will send it to you later on.
At least a link or two. So, but a little bit more. Do you have any specifics? Sort of what is the core for Vinnova now? Where will you put your money more specifically, or where do you see in 1 minute? So.
In 1 minute, we see that there's a tremendous AI potential all over the world. We're trying to find what Vinnova, where we really could make a difference. And we see that, of course, we have interesting companies like ULs that we co-funded from the beginning. So, but we see that we need to take a number of steps. We are looking into education, and as Fredrik so correctly pointed out, we need competence. We need to learn about AI. So we're looking into different nodes or centers for AI, both research and education, but we're not really sure how they should look like yet. We've done a number of investments in AI for health. We have financed a number of startups. And we see it in a lot of projects, especially within the automotive sector. But now, if we are going to do something new, what could that look like? And for me personally, I think AI, where we're trying to make computers think like humans, interesting, but what do we get? We get sort of more humans. I think it would be so much more interesting to make the computers do what we can't. So in order to say, look into solutions for the global development goals, I think that's sort of a more offensive and, at least for me, very appealing approach to AI. Could we use that for the problems that we are not able to solve? So I think that will be something.
Great.
Yeah.
Thank you. Christina.
Thank you. I'm Christina Henderson, and I'm head of the division for knowledge management and data analyst at Tillväxtverket, the Agency for Economic and Regional Growth. And our vision is to have more companies that want to grow and have the capabilities and courage to do so. And our main tool is to achieve it, our knowledge, networks and fundings. And we are mostly targeting small and middle-sized companies with our programs and initiatives. And we have a few government assignments for the time being, which are trying to target the digital transformation and support it. And, for example, exploring AI as well. I would like to mention a few of them. One is to enhance the digital skills in company boards and management, which is a new program that will start up now during this autumn. We also have something called digitalization checks that could be used for taking in external help in the company. For example, for measuring digital maturity, develop a digital transformation strategy, to have an AI strategy, for example. And we also have a program called Digilift, which is a program to stimulate digital transformation in the industrial sector and service providers closely linked to the industry. And we are offering here is a training program and a coaching program that could be, that is targeting mostly to small and medium-sized company within the industry sector.
Great, thank you. Now we know a little bit more, and you know where to talk to afterwards if you want to learn more about their programs. But given what we talked about in the invitation for this afternoon, is that there are a couple of areas I want you to all to answer and think about. And that one to start with, it's like I want to start with a quote because I think it was kind of really interesting in this context. It's by Kevin Kelly in Wired magazine. He said, "The business plans of the next 10,000 startups are easy to forecast. Take X and add AI." So in thinking about that, I want you to sort of think about and talk about in what areas will we see a new wave of startups building on AI, and what will society benefit from that? So we add that little component as well. I know it's a very easy question, so who wants to start?
Yeah, I could start. No, so it's like we machine learning engineers often joke about that. That's like machine learning is a lot like a fryer. You try it on everything and it sort of works. So you could try it on avocado or whatever, and it sort of like turns out pretty tasty. And like that, the equivalent is with machine learning as well, is that you try how it will be able to help you solve some complex solutions, and it usually adds quite a bit of value. But in particular, where we've seen it add a lot of value is these areas where you basically have combinatorial explosions. In that, like if you take education, for example, why a student answered a certain question incorrectly, just after having answered 10 questions, could be thousands of reasons, depending on how they interacted with the previous material. And being able to provide this analysis, looking through every single answer that student has done historically and optimizing the next question they should see, you have these combinatorial explosions. And that was sort of one of the key problems that was with AlphaGo, which we previously solved, in that I think AlphaGo, if you take chess, you have 10 to the power of 120 possible configurations or positions. But in playing Go, you have 10 to the power of 170. So you have this immense branching. And when you have that kind of branching in the problems, it gets sort of very complex for humans to solve them. So whenever you have that kind of combinatorial explosions, which is complex for humans to identify the exact reasons, machine learning systems can often be helpful in augmenting humans. And I think that augmenting aspect is actually really important. So McKinsey published a study in that only 5% of all jobs will be fully automated. However, 60% of jobs will be 30% automated. And I think that's really what we're going to see. We're going to see all of the professions, we're going to see parts of the jobs being automated and humans being augmented as a function of that rather than replaced.
Okay, who wants to? Fredrik? Then.
I can go next. So, I mean, another aspect is, of course, where you have interesting data sets. So, I mean, if you have interesting data, especially if you can combine interesting new combinations of different types of information, that's another rich area. I mean, if you have the data, access to the data, and that there are interesting problems that you can solve with it, then you have have a good start. That would be my.
And if you combine that with areas where investors and the customers actually see a gain or a possible market, I think that's the areas where we'll see the investments at first. But then I think that when we sort of move over to business solutions, there won't be so much writing about the investments, but I think AI might be more solid there. So I think right now, I just saw on TV last night, all the commercials have the word AI in them. Camera powered by AI, so it will be labeled everywhere. But where it will truly be, I think that remains to be seen.
It is the new black, that's for sure. Yes.
I think another sector that would probably be quite important as well is the public sector, because we have huge societal challenges that we need to consider during the coming years. And I think when it comes to AI and digitalization, we have a lot to do there to get processes smarter, to deliver the services to the citizens and the companies and so on. So that would be a sector also for a lot of startups, I think, and companies and entrepreneurship.
If you look at the patterns of where
you need to have it close to.
Yeah. Okay. If you look at the pattern of where the money of investors go, in the whole world, but mainly like in Silicon Valley, more than half of the startups in Silicon Valley are working on computer vision. And this is because of the problem that partly I tried to explain. Because number of cameras or surveillance cameras are increasing tremendously, and the number of cameras are much more than the number of people. So it's not possible to for people to see what is going on in the images and cameras. So we need to automate this process. The other place that is getting more popular is natural language processing, because this is the natural way that in future we interact with machines.
And to add to that, I think that we see investments in technologies, but now we will move on to investments in application areas. So sort of a classic pattern.
So before we open up for questions from the audience, if you each would think about you think about one possibility and one challenge for existing companies, when of course you have the startups coming in from one, they sort of push on that side, but how should existing companies, small, medium-sized, large, sort of work or think and see the opportunities and the challenges in this with AI? Who wants to go first?
Thank you. I think one of the things you have to do is to start. Start thinking about it and start trying, testing, exploring, and learn, because it's all about skills. You need to have the awareness up in the management, but you also have to have the awareness in the company in total. So you need to start up really, because I think we have been talking a lot about AI, but to kind of take it into your business, I think that is the difficult part. And I think you also need to consider it that AI and digitalization is business development. So you have to look at your processes. What can you do smarter than you're doing today? In what part of your business could you apply AI? And then you also have to look at data, because data is key. If you don't have a good knowledge of your data, you can't really do any AI. Sorry.
I think that for existing companies, you need to think about how are you creating value today and how can AI help you create value in the future. And that might not necessarily be that you need to apply AI to your processes or your product. I think that for some companies, the value in thinking about AI is that they have data sets that might be very valuable to someone else. And I think that's sort of an untapped market that we see. And for existing companies to actually think, okay, I might have a little gold mine here that someone else is interested in. I think that could be one key and one differentiator.
Think Google, think Facebook.
Then I can add on to that, because then you start to think about ecosystems. So instead of thinking about you as a single company providing products and services, think about what is your role in the larger ecosystem. Because I mean, if, for example, if you have valuable data or you have some kind of platform or something, if you open that up to third parties, they can generate either products or based on or they can provide content into your service. So I think this ecosystem thought is also very relevant. And I think a challenge here is that I mean, of course, competence and getting both access to competence and building competence is a major thing, but you actually need to combine the kind of business knowledge and the technical knowledge, and I think that makes that a bit tricky. And we also need to see it as a leadership question, that it's really important that it's coming from the senior management, that this is important, that they are really pushing this forward. And of course, hopefully you have engaged people in the organization that are already doing things, but they need encouragement and they need to get opportunities to take this further. And for that, you need the leadership aspect.
Thank you. Nassim?
I think other than I think other than identifying the source of value, which is very important, and also revisiting the business models and building data ecosystem, it's also important that like you have an open culture toward onboarding AI, meaning that you need to realize that there will be research involved. You have to work with like different, you have to try different methods and see what algorithm works and if it works at all. And I think it's very important that we set our expectations, adjust our expectations as well. AI can solve a lot of problems, but it's not like a magic box that can solve all problems.
You will?
Yeah, so I think one of the key opportunities and also which is going to be the biggest challenge is you'll have to fundamentally probably redefine your business models over time as a function of this. Because if you look at AI, what it's going to allow us to do in a lot of industries is to do a lot of exactly what we do today, but much cheaper and faster. And usually what happens then is that startups who don't have legacy business models are much quicker to execute and build businesses which are fundamentally sort of faster and cheaper than sort of the legacy players in the industry. So first you have to identify those areas where you have sort of processes which have historically been manual but very repetitive, and see how you could make those more effective with use of AI systems, and then be quick to sort of redefine your business model as a function of that. But really more broadly, I think what you probably had some at Vinnova, like big data startups historically. And what I see now is sort of big data is the problem. So when we meet partners, everyone has these immense data sets. And sort of how I see AI is a bit like the solution to that problem. So now that we have those big data sets, what can we actually do of them? So I think if you look at most companies, they've actually gotten pretty good at collecting the data, but now the next question is how to make good use of it.
So let's open up. There was someone that one in the front here, I think was first, and then one down there.
I take this one first.
Oh, this one first, and then one up here.
Yes, because it's easiest.
Okay.
Yes, thank you. Sorry, is it on? Yeah, I can check it. Please.
Okay. Thank you very much. Can you pinpoint which sector or sectors progressed furthest in commercially deploying AI?
So likely consumer products are the ones that you've seen the furthest. So if you look at YouTube, Facebook, Spotify, Netflix, most of those companies have deeply ingrained in all of their products. Their AI is pretty much controlling the full user experiences, and those are the ones where I think it's also like it's been easiest to collect the data and also deploy the solutions. If you look at education, education is interesting because education is actually one of the world's most data-rich industries. Partially, you could collect an immense amount of information as a student interacts with educational material. How long did it take for them to read an explanation? Which questions did they answer? How did they get that answer incorrect? What was the incorrect choice? And as they interact with that, you also have these cascading effects in that when you interact with material in trigonometry, that also says aspects of how you know geometry. So you have those cascading effects which generates immense amounts of data. And I think we're going to see pretty soon the adoption for most of the world's largest education companies deploying personalization systems into their learning products. So I certainly think that's going to be an industry which is going to adopt it quickly. I think industrial applications, it's been difficult to some extent because there's sort of this first problem that you have to solve in that they've actually not been as good in collecting the data. So I think first you want companies that build their products more around sensoring and data collection, and then on top of that they'll be able to offer AI. But certainly consumers, the ones you've seen the quickest adoption.
Do you want to add something, and then?
Yeah.
Do you want to add? Okay.
Yeah, so I think if you look at the biggest investment in the area of AI has been done by tech giant companies. And both in terms of research and also providing products and services based on AI. And basically they have attracted and absorbed all talents. So all other sectors, industrial sectors, they have lagged behind. So there are huge opportunities in all other industrial areas to onboard AI.
Okay. And just quick addition, I think parts of the health sector has been very, very keen on deploying AI to benefit for many, but that we don't see as much. So knowledge for doctors that are not specialized in certain areas is available through different types of AI-based systems.
Yes, a question?
Yeah, this is a question for the professor. How many billions of jobs will be wiped out by artificial intelligence?
Easy question to answer.
Yeah, none. Because, I mean, what's being automated is not occupations, as Joel already mentioned this study by McKinsey. So, I mean, what is being automated is tasks, activities that we do. And this particular study, they found, as Joel mentioned, I mean, that was less than 5% of all the occupations can be fully automated. But more than 60% of the occupations have 30% or more that can be automated. So most likely what we will see is that between 30 and 50% of the activities that you do today at work can be automated. But what we do see is that basically every occupation has too few people. I mean, you can take truck drivers, bus drivers, taxi drivers, healthcare people, teachers, all these areas there is not enough people. So actually the problem is not that jobs are being taken away, but it's the only solution to actually provide the kind of workforce that we need. We're not enough people to do all the things we need to have done.
Next question we have.
No, I just got this strong feeling when you were talking about the gold mine and the big data that it's tightly coupled to my privacy and my integrity. That's what I wanted to say. You can please address that if you want.
So I think that's a very interesting question, because it's a double-sided sword. On one side, I mean, you and most of us usually share very freely our data when we see the immediate need, and that we see that we get something out of it. But then, of course, we don't know what that data can be used for as well. And so it's not really a question about sharing or not sharing, but more what is a reasonable use of this data. So what I personally would like to see is much more that I control my own data. I don't mind sharing it with in different ways, as long as it's kind of owned and controlled by myself. I think that's one very important aspect. And I mean, I'm also involved in the European Union discussions around this. So the European Commission has a high-level expert group on AI where we are discussing these things regarding data and ethics and so on. And there are so many different aspects of this question. For example, liability, who is liable for things, about kind of transparency, being aware of what your data is being used for and how it's being used. So yeah, it's a hard question. But there are no obvious answers, and we also have to consider the I mean, take the kind of opposite view. I mean, could it be morally incorrect, or I mean, morally not accepted, not sharing your data? For example, assume that you have a very rare disease, and that if you share your data, you actually improve the chances of saving lives in the future. So by not sharing your data, you can actually risk other people's lives. Yeah.
So we'll take another question and we'll try to get the ping pong here. Yes.
I have a baby here that sounds like, but I'll try to have a higher voice. Since 2005, there has been network orchestrators or multi-sided platforms that have trended in the global economy. Microsoft, Amazon, Google, Facebook, Alibaba, Tencent, Baidu. And they have been lifted by the scaling-free internet and also matching models between producers and consumers. I'm coming to a question. Now, we see that AI is coming strong, but also other network supplying technologies like blockchain, which could change things. And also on the edge, we have local technologies like 3D printing, local printing. We have AR and VR, which are customer enhancing. On the big picture, on the market side, on the network side, how to orchestrate networks, how to orchestrate the whole markets, the whole systems that governs the world, and combinations of AI and blockchains together. Do you have any comments on that? That's my question.
Yeah.
No, but actually it's really interesting coupled to the previous question with blockchain and sort of how the data is controlled. I think that can help us solve some of those problems. But generally, I think you see these sort of S-curves in how technologies go to market, and I think AI has sort of it has had its winters, and it's now providing value. Netflix reported saving $1 billion using machine learning. Google DeepMind deployed their solutions for data centers and reduced the cooling cost by 50%. So I think we're now seeing at the point of the S-curve where AI is really delivering value. And I don't think the case is that for blockchain, for example. I think we're at a point with hype and investments being made, then we're going to see a crash. It's probably not going to be the same companies that were sort of prominent now that are prominent in the next phase of development. However, now the investments are being made into the field that will enable sort of the next generation of solutions. So I think AI is really here to provide value, but I think a blockchain will see a crash, but then we'll surely see value creation over time.
One more question, then we'll have some final words up here. So trying to keep us on time.
Yeah. Yes, I have a question about something I found very interesting that was just touched upon really shortly, and that's about the potential of AI to contribute to achieving the Sustainable Development Goals and sustainable development in general. Could you just name like some potential that you find maybe is the biggest potential within the area that you work in for AI being used in order to contribute to sustainable development. And if you find that question difficult to answer, you can also say something about what is actually needed in order to for AI to be used for contributing to sustainable development.
Who wants to go first?
I can go first because this is a very important subject to me personally. I think where AI can help us here is that we have the 17 goals and all the sub-goals, and they're very difficult to separate and they're indivisible, so we need to work with them at the same time, and if we do this, we might harm that goal. How can AI help us to do these very, very complex evaluations of different measures that we need to take to sort of stay in the donut of sustainability? So for me, that's one way of using AI here. And just say climate models, ocean models. I think there are so vast numbers of data there, so that's where AI really could help us.
I mean, I also see tremendous opportunity in kind of improving the efficiency of all our systems. I mean, you will mention this, that just improving the energy efficiency of data centers by a huge amount. And I mean, if we get autonomous cars and so on that are electricity driven, that you need fewer vehicles. And I mean, you have also opportunity to do this telework and so on. So I think just energy optimization will probably save a lot of be very beneficial for the environment.
And in the future, we might not only have car-free days, but computer-free days, just to reduce pollution and climate damage. So let's look forward to that.
To end, I would like you all, we're going to go over just a few minutes, but I want everybody of you to sort of add top 2 things that you think is so important to think about when it comes to the future development AI, particularly with the focus on sort of entrepreneurship, innovation, small business area.
Okay. So I mean, I would say the most important to me is that it's not either or, but both. So I mean, it's not about replacing people, but more getting us to be better at doing our things and being better at, for example, achieving the sustainability goal. I think that's the number one. And then the second one is to focus on competence development. I think that you will gain a lot in your company from that.
I think it's important with the skills and the competence, the value creation of data. I think data is the key here. And also to try, test, explore, try, learn, and start now.
So generally, if you just look at sort of the investments that are done in AI, in an AI-first company, so companies that focus on basic research within AI, we haven't seen too many bets like that in Europe generally. So if you look at DeepMind, which were the developers of AlphaGo and has been prominent, publishing a lot of the most interesting papers lately, they were funded by US investors and subsequently Google. And I think what's really important is that we also make that kind of bold bets on basic AI research in Europe as well. And if you look at our research, we were taking a new approach to personalizing education, which was it was a lot of technical risk in the beginning. And we had Vinnova who funded us at that stage. And I think that's going to continue to be very important, that we have people who make the bets on basic research and in AI in particular, and that we get investors who understand the field.
I'd like to add that for the future and for companies, if you can create trust or an illusion of trust, people will be more willing to share the data and think about their privacy. And I think this is a key issue for the future.
I think there are many problems that AI can solve, but there are some aspects that AI cannot solve. And it's interesting to start investing and working on those problems as well. Like AI makes decisions, but it cannot explain why it has made that decision. So interpretability is one of the biggest unsolved issues in AI. Another problem is another issue is that how can we certify AI-based products. Like we cannot verify AI models. And I think it's also important to focus on these unsolved issues as well.
Thank you very much. For me, it's clearly we just sort of scratched the surface in talking about AI. I mean, it covers so many areas, has so many dimensions, and so many sort of implications for the individual, for organizational companies, and on society. So hopefully we can sort of come back to it in many, many times and talk about it, because it's very intriguing, very interesting, and very, difficult to grasp at once. I hope you learned some today. I've learned quite a bit. And with that, I want to turn the floor over here to Helene. And I would just like to thank you, the panel. It was great. Good job.
Okay, do you hear me? Okay, perfect. I want to thank Magnus, the speakers, the panelists, and also our main partners, Tillväxtverket and Vinnova, and our partner Länsstyrelsen in Stockholm. Thanks to their support, we can arrange Estrad free of cost for you. We have 2 gifts for our excellent speakers and panelists. First, we like knowledge, so we support UNICEF's School in the Box. And we also like recycling. So we have a bowl from Torstensson Art made of recycled glass. And I also want to thank all of you that have celebrated Estrad number 200 with us. Next lecture is on October 9. You will get an invitation in your inbox tomorrow. So we hope to see you soon. Thank you. And now we open up for mingle. You can start in the back, and we will soon serve here too. Thank you. Perfect.